Very good morning to everyone. Myself, T. Muthukumar, Assistant Professor, Department of EEE, Kongunadu College of Engineering and Technology. So today I'm going to present a lecture on vacuum breakdown in high voltage engineering subject. So before that, so we are entering into the topic. So different types of insulating materials or insulation types are available in high voltage engineering. So the different insulating materials are gas, liquids, vacuum, and solid. So these type of insulations we are using in high voltage engineering. So we use the liquids, commercial liquid and pure liquids, and solid dielectrics and composite dielectrics. So sometimes we are using gas as a liquid medium. So, but today we are going to discuss vacuum insulation. So vacuum insulation, so is one of the oldest method for the purpose of using insulation. So according to that Townsend theory, so breakdown for the insulating material in the gas, so is depend on the growth of the current in the gap that is between the electrode terminals. So this growth of current is depends on the charged particle. So most of the electrons is the main reason for the breakdown. So charged particles so plays a very important role for the breakdown purpose. So this current growth will be main reason for breakdown in all the material. Vacuum insulation also. So this charged particle plays a very important role. So we are taking as a vacuum as a insulating material. So in this case, so there is no charge particle, there is no electron is available in vacuum. This is a perfect medium means perfect dielectric material means. So there should be no conduction and no conduction will be available. So this vacuum is called perfect insulating medium. So, but however, in practical applications, so some of the breakdown will be possible, because even if you are applying the high electric voltage between the electrodes of the electrode terminals, so even a small amount of current will be formed. This current will be responsible for the breakdown in the vacuum insulation. So here presence of metallic electrodes and insulating surfaces available within the vacuum electrodes. So this complicate the issue. So some amount of current will be formed. So this current is the reason for the breakdown. So next, what is meant by vacuum? So vacuum is a system so which is used to create the vacuum in which the pressure is maintained at a value much below the atmospheric pressure. So generally, so we are measuring atmospheric pressure in terms of millimeters of mercury. So one standard atmosphere is equal to 760 millimeters of mercury at a temperature of 0 degree Celsius. So the term millimeters of mercury has been standardized by our International Vacuum Society, and also it is mentioned TOR, that is tar value. So another unit of measuring of vacuum in a particular atmosphere is millimeters of mercury or tar. So the vacuum has been classified based on the vacuum range or TOR value. So it is classified into three types. So one is a high vacuum. So the range of this TOR value is 1 into 10 power minus 3 to 1 into 10 power minus 6. So this range is called high vacuum range. So second one is very high vacuum. So range is 1 into 10 power minus 6 to 1 into 10 power minus 8 tar value. So third one is ultra high vacuum. So the range is 1 into 10 power minus 9 tar or below. So these are the different classification of vacuum based on the tar value. So for our insulation purpose, so generally high voltage engineering, so we are using insulating medium, vacuum as insulating medium. So very high vacuum, we are preparing compared to high vacuum we are preparing compared to other two types. So in this range, the vacuum torr value is equal to 1 into 10 power minus 2, 1 into 10 power minus 9. So next, moving to vacuum breakdown. So based on the Townsend type of discharge in a gaseous breakdown, so electron cells multiply due to various ionization process, and then electron avalanche is formed. So in gaseous breakdown, so first electron multiplication will be happen due to the various ionization process, and then electron avalanche is formed. So this is for the Townsend basis of gaseous breakdown. So we are discussing the vacuum breakdown. Even if a high vacuum, so if the electrode are separated by some few centimeter of distance between the anode and the cathode terminal, so electron crosses the gap without encountering any collisions. So compared to gaseous breakdown, in this vacuum breakdown, so no need for any ionization process. So automatically applications of high electrode, so electron crosses the gap without encountering any collisions. So this is the reason for the current growth. So the current growth prior to the breakdown cannot be due to the formation of avalanche. So in gaseous breakdown, electron avalanche is the main reason for the breakdown, but in vacuum breakdown, the current growth due to the electron crosses between the gap is responsible for the vacuum breakdown. So main process is, so if you apply the high voltage between the electrodes, so in between the vacuum gap, so some amount of gas molecules will be liberated or released due to the various mechanisms. So if a gas is liberated in the vacuum gap, then the breakdown can occur by the Townsend process. So first, gas molecule will be released, and then gaseous breakdown according to the Townsend process it will be happen. So finally, vacuum breakdown will be happen. So the three different categories are available, or different mechanisms are available for the liberating the gas in the vacuum gap. So these mechanisms are particle exchange mechanism. Second one is field emission mechanism. Third one is clump theory. So we will discuss one by one elaborately. So first one, particle exchange mechanism. So in this concept, so charged particle will be emitted from one of the, so charged particle so can be emitted from one of the electrode under action of the high electric field. For example, so we here two electrodes are available. So one is cathode. So this is cathode terminal. So this is the two electrodes are available. Two electrode and so one is cathode, another one is anode. So cathode and anode is the electrodes. In between the we are placing the vacuum as insulating medium. So according to this particle exchange mechanism, one electrode from the one electron will be emitted. So from the cathode, electron will be emitted. So in this electron will be emitted from the cathode surface. So once the electron is emitted from the cathode due to the applications of high electric field, so this is moves into the gap or accelerated into the gap and impinges on the other electrode, that is anode. So it releases the oppositely charged particles. So it automatically releases the oppositely charged particles. This is the main mechanism. So electron is emitted from one end, one electrode. So it will be accelerated towards the gap due to the high applications of electric field. Finally, so it strikes on the second electrode means, so automatically opposite charged particles will be emitted. So this is the fundamental operation. So these particles are collected by the applied voltage back to the first electrode. So after striking the anode, so it releases the opposite charged particle, that is a photon will be emitted here, and also one of the another particle, that is positive ion, will be emitted. So these particles moves towards the first electrode, that is moves towards the cathode in the gap. So it strikes on the cathode surface means, so it produces the release or produce or release the more of the original type of particles. So secondary electrons will be produced. So if the number of electrons will be increases, so up to the certain level means automatically current growth will be possible. So this cause the breakdown in the gap. So in the process, this process becomes a cumulative or a chain reaction occurs, which leads to the breakdown in the gap. So in this mechanism involves electrons. This mechanism involves electrons. Electrons, one of the charged particles. So photon, positive ion. So under absorbed gases at the electrode surfaces. So initially, so electron will be emitted from the cathode surface. So electron is emitted from the cathode. So under it, its impact on the anode releases the photon. And so it's important. So it impact releases the photon. So this term as photon is here mentioned C. So some notations are given. For A is called positive ions, C is called the photons, B is called electrons emitted by the positive ions, D is called electrons emitted by the photon. So initially, electron released from the cathode, it strikes on the anode, it releases the opposite particles, photon, that is positive ion. Second photon to move towards the first electrode cathode. So it strikes on the cathode surface, it emits the more number of original electrons. So this is the electron emitted by the photon. So B is called electron emitted by positive ions. Similarly, so D is called electron emitted by the photon. So photon produces the more number of electrons, and also positive ions produces the more number of electrons. These electrons is called secondary electrons. So these electrons are the responsible for the breakdown. So mathematically, the breakdown conditions is so AB plus CD greater than 1. For this condition, so AB plus CD greater than 1. That is, A is called positive ion coefficient, B is called electron emitted by the positive ions. So product of A and B plus product of C and D. C is called photon, D is called electrons emitted by the photon. The product of C and D. So overall, this addition is greater than 1 means automatically breakdown occur. So this is the breakdown conditions for this mechanism, this breakdown mechanism. So initially the Trump and Andy-Greb measured this coefficient, but it is too small for the process to take place. So later they are modified this criteria. So with negative ions, and the criterion of breakdown becomes modified. AB plus EF is greater than is equal to 1. So here E and F represent the coefficients of negative and positive ion liberations. So E is called negative ion liberation by the positive ions. F is called liberation of positive ion by negative ions. Okay, so experimentally they determine these the product values E and EAF, product of EF. This is very close to unity for copper and aluminum and stainless steel electrodes. So to make the mechanism applicable at a voltage of about 250 kilovolt. So if you apply about 250 kilovolt in the copper and aluminum stainless steel electrodes, so the breakdown will be possible according to this condition, AB plus EF greater than 1. So next breakdown mechanism is field emission theory. So first one is particle exchange mechanism. The particle is moved from one electrode to another electrode. It produces the opposite charges. So more number of secondary electrons will be formed. So this causes the breakdown in the gap. So next one is field emission theory. So under this, this is classified into further subdivided into 3 types. One is anode heating mechanism. Another one is cathode heating mechanism. Third one is Coulomb mechanism. So we will discuss one by one elaborately. So anode heating mechanism. So in this mechanism, so electrons are produced at small micro projections. So electrons are produced at a small micro projections on the cathode. So due to the field emissions, okay, pambered due to the anode. So this is cathode terminal surface. This is anode surface. So here electrons are emitted or produced from the small micro projections on the cathode. So due to the field emission pambered methodology, and the anode causing a local rise in temperature. So here, so temperature here, temperature, that is local rise in temperature will be possible. So it releases the gases and vapor in the vacuum. So in between the cathode and the anode, vacuum will be available. So small micro projections on the cathode produces the or releases the causes the local rise in temperature. So temperature will be increased between the gaps. So automatically gas bubbles or gases will be released from the vacuum. So gases and the vapor are released from the vacuum molecules. So these atoms, so ionized these electrons. So cathode emits the electron due to the field emission pambered method. So and also temperature rising gap. So these electrons so ionizes the atoms of the gas. So gas molecules are produced. So this electron combined with the atom of the gas, ionization process takes place and produce the positive ion. So by the process, positive ion will be produced. So these positive ions again colorated in the gap and again moves into cathode or arrives at the cathode. So increases the primary electron emissions due to space charge formation. So more number of electrons will be induced at the end. So secondary electrons will be produced. So initially, so electrons produced at the micro projections on the cathode. So this is the reason for the local temperature rise. So automatically vapor and gas molecules will be formed. So these electrons ionizes the atoms of the gas and produce the positive ions. So these positive ions strikes into or arrive to the cathode and produce the more amount of secondary electrons. So number of electrons will be increased. So in this process. So this number of electron will be sufficient to cause the breakdown means. So here a breakdown will be occurs. So next method is cathode heating mechanism. So in this method, so this is the cathode electrode, this is anode. So near the breakdown voltage, so every material have some breakdown voltage. So nearby the breakdown voltage of this gap, so sharp points on the cathode surface is the responsible for the current growth. So sharp points on the cathode surface is responsible for the existence of the free breakdown current. So current, it causes the rise in current. So this current causes the resistive heating at the tip of the cathode. So due to the resistive heating, the current density is increases or reached at the critical conditions means. So this current so causes the melting of the tips and also explodes the tips. So thus initiating the vacuum discharge. So this mechanism is called field emission mechanism. So small sharp points on the cathode surface is responsible for the free existence of the current growth. So if voltage, applied voltage is reaches the breakdown voltage, it will be happen, the current growth will be happen. So due to this current growth, resistive heating process will be happen. So due to the resistive heating, the tip of the cathode will be melt and explodes. So this is the initiation of the vacuum discharge. So this initiation is depends upon the condition and the property of the cathode surface. So this is purely depends upon the conditions of the cathode surface and the property of the cathode surface. So the electric field, applied electric field intensity is in the order of 10 power 6 to 10 power 7 volt per centimeter is the effective cathode electric field for the cathode heating mechanism process. So third method is clump mechanism. So basically, so this theory has been developed for the following assumptions. So these are the three conditions. So at conditions A, so this is the condition A. So here clumps are attached, loosely attached at the surface of the cathode. So this is anode surface. So initially, if you are going to apply the high electric field, so the loosely attached clump will be charged. So after that, so this is the second condition, second stage. This due to the high voltage application, the clump is detached from the electrode surface and accelerated across the gap. So third stage, once it reaches the or crosses the gap and reaches the anode means, so it produces the cloud of metal vapors. So once the vapor is produced means, so automatically, so according to the Townsend process, the gases breakdown will be happen. So basically, this theory has been developed by the following assumption. The first assumption is the loosely bound particle exists one of the electrode surface. According to the diagram, the loosely bound particle exists in the cathode surface. So on the application of high voltage, so the particle gets charged and gets detached from the mother electrode. That is, it is detached from the cathode and is accelerated across the gap. So the breakdown occurs. So due to a discharge of, so this clump strikes on the opposite electrode means, so automatically vapor or gas will be released. So this after this process, normally Townsend gaseous breakdown will be occur. So Gramberg was the first scientist to propose this theory. So he initially assumed that the breakdown occur and the energy per unit area, that is the W, is delivered to the target electrode by a clamp. Energy delivered to the target electrode by a clamp exists the value C. So energy delivered to the target electrode by a clamp with exists value C means the breakdown will be occur. So the breakdown condition is, so VE is equal to C. So this W is called the product of gap voltage and charge density of the clump. So later he modified this relationship with the help of electric field. So V into E equal to CS. This is the criterion for the clump mechanism. So already I explained, initially the clump is loosely attached at the first stage. So after applications of high electric field, so it gets charged, so and detached from the, so it will be charged. So after high application, it will be detached from the cathode surface and crosses the gap. So after striking the third stage, after striking the anode surface, it produces a more number of vapor molecules. So automatically after vaporization, so Townsend gaseous breakdown will be possible. So finally, I will conclude my today's lecture. So today we discussed vacuum insulation. So this is one of the very old method compared to other insulation methods. We are using the different types of insulation like liquids, solid dielectrics, gaseous dielectrics. This is one of the oldest method, vacuum insulation. Generally, current growth is responsible for the breakdown according to the Townsend theory. But here there is no avalanche formation will be available. So if you apply the high voltage, so automatically in a vacuum, due to the presence of metallic electrodes and insulating surface inside the gap, some current growth will be possible. So this is the responsible. So vacuum means, so we are going to maintain the pressure below the atmospheric conditions. That is called vacuum. But generally, it is measured in terms of mercury, millimeters of mercury. So, and another name is called a TAR value. So specifically, high voltage engineering, we are using high vacuum as a insulating medium. The range of this TAR value is 1 into 10 power minus 3 to 1 into 10 power minus 6. So vacuum breakdown means, so initially we are going to based on any one of the breakdown mechanism, we are going to liberate the gas or vapor molecules from the vacuum, and then based on Townsend process, breakdown will be happen. So three different types of mechanism are available. So one is a particle exchange mechanism, field emission mechanism, Klump theory. So in particle exchange mechanism, so to in between the cathode and electrodes, the vacuum is here. Vacuum is placed. So initially, one electrode is responsible for the production of the electrons. So these electrons will be released from the cathode and moved across the gap due to the high electric field. It reaches the anode. So once it strikes on the anode, mean it produces the oppositely charged particle. So it produces the photon and a positive ion. So this photon and positive ion again strike into the original or mother electrode, that is cathode. So it produces the secondary electrons, more number of secondary electrons. So this secondary electron is the more responsible for the current growth. If the process is chain reaction means, so a certain current limit, breakdown will be occur in the gap. So it is called particle exchange mechanism. So electrons moves from one electrode to another electrode, it will release the opposite charged particle. Again, this opposite charged particle releases the mother electrons, original or secondary electrons. So more number of electron reason for the breakdown. So the breakdown condition is according to the condition AB plus CD greater than 1. So this is the particle exchange mechanism, breakdown mechanism. So later this will be modified AB plus EF greater than 1 by the Trump and Van de Graaff. So field emission mechanism, anode heating method, cathode heating mechanism. So in anode heating, so cathode electrons will be emitted from the small micro projections. So these electrons ionizes with the atoms of the gases and produce the positive ions. So these positive ions arrive at the again cathode surface, means produce the more number of electrons, that is secondary electron. So the secondary electron is responsible for the breakdown. So cathode heating mechanism. So due to the sharp points on the cathode surface is responsible for the free breakdown current. So it after is a resistive heating, it raises the current level. So automatically current density will be increases beyond the limit, means so it melted and produced the vapor or gas molecules in between the gap. So this gas molecules are discharged by the Townsend process. Finally, breakdown will be happen. So last one is clump mechanism. So in clump mechanism, so initially the clump of electrons will be loosely bounded in the cathode surface. After the applications of high electric field, the clump will be get charged and detached from the cathode surface. So and accelerated towards the gap due to the electric field and reaches the cathode mains. So it will produce the vaporization vapor. So this vapor will be discharged according to the Townsend theory. So automatically clump mechanism will be happen. So finally I conclude my session. So thank you.